Question 21, a parallelogram and included proof are shown. So it tells us this is a parallelogram, opposite sides are parallel, and we are trying to prove that we have a pair of opposite sides that are congruent. We're trying to prove that this segment is congruent to this segment. Well, let's see what we can do. So we have the given in there, it's a parallelogram. And then we have that the opposite sides are parallel in statement 2. That's the definition of a parallelogram. Check. Let's examine what this is. Angle ZWY, that's this one here, is congruent to angle XYW. What's this one here? So why would that be true? Parallel line, transversal. I am just highlighting the lines that make up those angles. That's the alternate interior angle theorem. Let's see if that's consistent with this next statement that's in the same line. ZYW, that's this one here, is congruent to XWY. So in that case, we are referring to parallel line, transversal. In both cases, those are the alternate interior angles. Alternate interior angles are congruent when you got parallel lines. In class, we would just say the alternate interior angle theorem. Remind you, on the state test, these are drag and drop. You would just drag this up and put it in the box. All right, great. Next we have segment WY is congruent to segment WY. Hopefully that jumps out at you. That's a reflexive property. Specifically, we called that congruence of segments is reflexive. It's a more appropriate term. They just generically said reflexive property, but that's cool. I'm going to mark that in the picture. That's this here. It's congruent to itself. Then they're saying we have two triangles that are congruent. Triangle WYZ, that's this triangle here, is congruent to triangle YWX. Now, why would that be the case? Well, it looks like we have two angles and included side, angle, side, angle. That's the angle, side, angle congruency postulator theorem, which is this one right here. And then finally, we have, I'm going to get rid of some of this stuff here. We have segment WX is congruent to segment YZ. Well, those are corresponding parts of congruent triangles, CPCTC. Got to be careful here. This one says congruent, this one says similar. These are not similar triangles. I mean, they are technically similar, but this is based upon the definition of congruent triangles, CPCTC. That's this one right here. Done.